Okay, welcome to day 2 of Algebra Regular. I'm going to be calling the videos day 1, day 2. So yesterday was day 1, today will be day 2, tomorrow will be day 3. Some days there might not be a video. And I will post the work on Google Classroom as day 1, day 2, so take a little bit of the confusion out of it. Quick little recap, I will post the solutions for yesterday's homework so you can check over it. Ask me any questions, feel free to. Just for example, number 8, we have a times the square root of a, and we are asked to write it without a radical. So we're going to change that radical into a rational exponent. A outside here is to the first, so it just stays as a times a. The index, which is understood to be 2, is the denominator, and the power is the numerator. That's as simple as that. Now, past that, we have to multiply these together, and the basic rule is when you multiply like bases, we're going to add those exponents. So we need a common denominator, and of course 1 is the same as 2 over 2. Multiplying these bases together, I get a to the 3/2, and that would be the final answer. Okay, the only thing that we're going to do new today is we're going to go in reverse. So if I have x to the 4/5, I would say write that with radicals and always in simplest form. So again, that denominator just becomes the index. So I'm going to have the 5th root of x to the 4th. And then I look to see if I can simplify it at all. Well, if it's the 5th root and I only have the 4th power of x, I can't take any x's out. Remembering, simplifying radicals, a little bit of a review. If I've got the 3rd root of x to the 5th, I can take that out because that number is greater. What that means is I've got x cubed times x squared, same as x to the 5th. The cube root of x cubed times the cube root of x squared, which is x cube root of x squared. The power in here always has to be less, and we have to simplify these radicals. So the conversion right to radical form is not that difficult, but then simplifying radicals can get a little bit more challenging. Now in practice, we really wouldn't take it that long and that hard. All I would do is if I have the 4th root of x to the 15th, obviously I can take some x's out, but the question is how many? Well, x to the 4 times x to the 4 times x to the 4th. No, I'm not going to do it that way. I'm simply going to take 4 goes into 15 3 times. So I can take 3 x's out, and the remainder, 4 goes into 15 3 times, so 4 times 3 is 12. I have a remainder of 3, so there are 3 left inside. That's the quick, easy way of simplifying those. All right, so let's say I have 5x to the, 2/3. A simple mistake would be to take both of these and put them underneath the radical. Remember, the number does not go with the x. It is a factor by itself. It has a power of 1. So it stays on the outside of the radical. It's the cube root of x squared. Simple as that. If I have something that's in parentheses, say 2y to the 2nd raised to the 1/4. Well, I could certainly raise each one of these to the 1/4 power, but this whole thing is simply underneath this radical. So that means I have the 4th power of 2y squared. Well, what happens if I have x to the 3/4 times x to the, I'm sorry, not x, let's do y, to the 1/4. Well, I have a denominator that's the same. So they are both going to go underneath the same radical, and that's going to be the 4th root of x cubed y to the 1st. So I don't have to simplify that any further. The trouble comes when I have x to the 1/3 y to the 3/5. I can't put those underneath one radical until I get a common denominator. So here we go on with fractions. 3 and 5, of course, you're going to have a common denominator 15. y is going to have the 15. So I'm going to multiply this one by 5 over 5. So that's 5 over 15. And this one gets multiplied by 3 over 3. So that's 9 over 15. Giving me the 15th root of x to the 5th, y to the 9th. Now some of these numbers are going to get large. These you're not used to it. It's okay. Whatever the number is, it is. The final one is going to be the most difficult because we have to remember how to rationalize a denominator. So if I have the square root of x, let's say 2 over that, I can't have the radical in the denominator. So if it's a square root, it's easy because you just match whatever is here, you multiply it by itself on top of one another. So that's going to be 2 square root of x. And just for explanation, square root of x times square root of x is square root of x squared. Note, I want this power to be the same as the index. With a square root, it's easy. That gives me 2 square root of x all over x. It gets a little more challenging when I have a cube root or a fourth root. So let's say I had x over the cube root of x. Well, I know I'm going to multiply by 1, and I know it's going to be the cube root of something over the cube root of something. So I look at whatever power I have here. It is only to the power of 1. It needs to be 3. So it's simply add up whatever I need. I have to have an x squared here. So that gives me x times the cube root of x squared all over. The cube root of x times the cube root of x squared is, of course, and you don't have to write this step, the cube root of x cubed. But we know the cube root of x cubed, that's why we did this, is going to just be x. So I've got x cube root of x squared all over x. My x's are now factors that are common that cancel out. So that gives me the cube root of x squared. Now, how's that going to look with the rational exponents? Let's say I have, I'm going to run out of room here. I'm just going to flip this over. Get this out of the way. I'm going to have x to the negative 3/4. Well, remember, I can't have a negative exponent, and I can't change it to radical form until it is a positive exponent. So I have to create 1 over x to the positive 3/4. Now I've got 1 over the 4th root of x cubed. Again, simplify if you can. The very last thing I want to do ever is rationalize the denominator. So I know I got to get rid of this radical in the denominator. It's simple. I'm going to multiply by the 4th root of something over the 4th root of something. I need to make this x cubed x to the 4th. Well, I'm only missing 1x. So it's the square root of x over the square root of x, or rather 4th root. Multiply the numerators, 4th root of x all over, well, the 4th root of x cubed times the 4th root of x is simply x, because this is the 4th root of x to the 4th, which equals x. That's why we chose it. Alrighty, hopefully that's enough. I didn't get any questions. Please feel free to ask on Google Classroom about the questions. Again, this is day 2 video, which is actually on Tuesday, tomorrow, the 24th. I'm putting them on a day ahead of time. If you want to keep a day ahead, that's fine. And I will post on Google Classroom a day 2 worksheet, which is just the back of the one you got yesterday. And please only do 10 through 20. I will post that there. Don't try the 21 through 30. They're a little more difficult. Well, they're very similar to this, but you know, if you want to go ahead, you can certainly give them a try, and then you'd even be more ahead. Alrighty, talk to you later.